Hello, this is Professor Neshiba, and I'm here to help you out with the computational guided inquiry for PChem, inferring model parameters from gas compressibility. And there's these assessments as usual, and the pre-lab for this has you looking up some things on the web and downloading some files from the our Moodle site. But I want to jump straight to equation 2 here. Because equation 2 goes something like this. You're going to download the pressure and the temperature from the Moodle site, and the experimental data that we have here is the mole density, and we're going to want to create a new variable called the gas compressibility factor, Z, from those data. So let me just take you off to Python, and here's what the template's already got for you. It's loading the pressure as a vector, temperature as a vector, and the rho, which is a gridded data set. It's a function of temperature and pressure. And the next line that you'll add in just makes gridded variables out of the pressure and temperature, just as we've done in the past. Now then, how are you going to calculate Z? Well, we want it to be a grid, so I'll say Z grid equals, and our formula just said, take the pressure and divide it by rho RT. Okay, so that's going to be P grid divided by the rho, which is, we need to make sure it's the gridded guy, rho grid times R, which we've defined, times the temperature grid. Okay, and hopefully that will work out. So let's see if it does. And since I didn't get any errors there, that means it seems like it was just fine. Now, one thing I just want to mention is if you want to double check on the size of your variables or anything like that, whos is a pretty handy command. It just says, okay, I've got P, which has 14 elements. That means we have 14 pressures. And we've got the temperature. We've got 9 elements. That means we've got 9 temperatures. And the gridded data sets then are 9 by 14. That is the 9 rows for 9 temperatures and 14 columns for 14 pressures. And we've got the rho, which looks like that, and the Z, which looks like that. So the last or second to last thing on this is to make a graph. This is pretty much boilerplate, just similar to what you've done in previous sessions. So I'll just see whether that works for me. And there we go. So there's a thermodynamic surface of Z as a function of the pressure and the temperature.